Hello, I will be doing a little exposition on some work I'm doing connecting processing Pachube, Grasshopper, and Arduino. Um, First thing we're going to want to do is load up our firmware onto the Arduino. And you can find that with the folder that you've downloaded from the Arduino site under Libraries, Firmata, Examples, Standard Firmata. Now I'm just going to go ahead and compile this. While that's compiling, I'm going to open up my processing. So it's done compiling. Now that it's finished compiling, you actually have to push it up onto the board. So now it's uploading onto the Arduino. Meantime, I'm going to open up my input device sketch. Oops. Alright, so here's my sketch. The firmware is done uploading, so you can just close out of the Arduino IDE. Now you just have processing and your Pachube values to push into processing. So now I will get this running. The display window will be coming up, and now you have my sort of Arduino target. Connected to Arduino, I have a breadboard which has a potentiometer and a button. Now, the potentiometer allows you to control one dimension at a time, and when you hit the button, as you see, now motion in the Y direction has been activated. You're now moving in the Y direction. Hit the button again, you're in the X, hit the button again, you're in the Y, so on and so on. So now I want to send my Pachube parameters that I've collected, and just kind of get this going again, and there they are mapped onto my processing sort of input device field. So what this allows me now is another dimension of parameters that I can now use in Grasshopper based on my Pachube data. So for example, say if I really want a lot of this guy, I'll just move my guy there. Now I'll start moving him in the Y direction. Oops. And there it is. It's a bit jumpy because it's a really loosely connected potentiometer onto onto this little board. But now you see, so since it's closest to here, the way I have it set up is that in addition, it actually has a very certain distance away from my target. In my input receiver definition, I am receiving this input. So every so often, so what I have is the original Pachube value, the remapped X, remapped Y, and the distance. So as you can see, as I move this guy, the distance changes. Same thing with my input 2. Everything's good. Now the reason why it keeps flashing like that is because I'm updating information. I'm updating the output file every second and a quarter. The reason for the delay is because since Grasshopper is much slower than processing, if I was to try to change this file or update this file every 1/30th of a second, or every 30/100ths of a second, processing would then try to actually open up the file while Grasshopper is reading and cause an exception to be thrown, and your sketch will crash. So now just a quick kind of run through of what's going on here. My Pachube, this is just a clunky way of making it convenient for me to just list the feeds that I want, and then the individual desired data stream paths. I could have easily just copy and pasted the path, fed it into the feed, but whatever, I set this up for myself. ultimately producing one single string by concatenating, by joining all the strings together, and then sending it via UDP using ghowl, via UDP to processing. So now to make the Grasshopper UDP connection, use this library for Arduino, and whenever you use Arduino, you also have to hook up the serial port library as well. I set up all my variables and so forth. Right, this is the 2 1/4. This is the delay that I've set up for myself. Now, as a string, set my IDP for this is obviously the UDP G8 Grasshopper setup. So my IDP, my port in, I set up my UDP object. I set it to listen. Now, for my pins, I have my button pin, an X LED and Y LED. I've set up on the breadboard actually 2 LEDs to tell me which direction I have control of at the moment, X or Y. I tell it to be input. I tell the button to be an input device and the 2 LEDs to be output device. And at the end of this, I set my button state to X, and I digitally write high to my X LED pin. High meaning 5 volts, which means you've got power. The other option is low, meaning 0 volts, which means you don't have power. Or there's no power getting to the device in order to activate its functionality. You have the draw. I search for my button. Basically, when my digital read of the button pin is high, that means that the button is pressed. That means that the connection is, that the switch is in place and the circuit is complete. So it is reading that it's getting 5 volts. So whenever it reads that it gets 5 volts, it flips whatever state it is in, turns one light on, one light off, and then I have to delay it. I find 0.15 seconds to be fine, because if you don't have a delay, it's gonna continue reading high. So I need this delay to give me time to unpress the button. Now for the potentiometer, it's something similar, and this just all gets this is for the save count here, but this all just does the work to update my information to send back to Grasshopper here, and this is just in case that there is no change in the potentiometer. Enough to receive, this is never called explicitly, but is implicitly called whenever a new UDP connection, or excuse me, whenever a new string, or whenever a string is being passed through the UDP port. And it receives this, and I've set up my own parsing little process. I've set it up so that it prints out my string. Here's my input data. Here's my largest and smallest guys. My remapped values. Now, what's nice about these remapped values is then since processing stores its pixels within one single array, I've now basically remapped them to be in their index. I've remapped them so that these fall within one of the pixel indexes. And yeah, this is pretty all straightforward. Just a lot of bookkeeping. And then ultimately at the end, when I send back my creator, I open up the file, I send it the GH parameter, the remapped parameter, but notice divided by its width. So this is actually giving you its X dimension, and this is giving you its Y. And that's about everything. Thank you very much. Bye.